Hello, everybody, and welcome to the first of our webinar series on blockchain with IT Masters and Charles Sturt University. My name is Jack Stewart, and we are joined by the wonderful Dr. Rich Lane this evening, or any time of day that it might be where you are watching this from. Thanks very much for joining us. This is the first week of a 4-week series of our newest short course on blockchain. Looking forward to it a whole lot. We've got some really, really great content to cover for everybody. A little bit of housekeeping just before we begin. It would be really, really fantastic if we could keep observations and questions that you might have for other participants, questions about the administration of the course and things like that to the chat function, and direct our questions that we have for Dr. Rich to the Q&A if those questions are about the course content itself. That way we can keep our Q&A sections as efficient as possible. Speaking of, apologies in advance, it does seem very unlikely that we are going to be able to answer everybody's questions. As usual, the way that we can get around that is to, if your question is not answered, please engage in the discussion forums with other students and also with Rich. You can access those in your Moodle, which you can access through learn.itmasters.edu.au. You should be able to log into that with the details that you used to sign up for this short course. Speaking of that as well, that learn.itmasters.edu.au is also where you will find the recordings of all of the course content. So that's the webinar recordings, which you will be able to access within 24 hours of this webinar being completed, as well as all of the written materials and any links or other relevant or interesting material that your course mentor has uploaded at that learn.itmasters.edu.au, which Lily has very helpfully popped in the webinar chat. Big thanks also to Lily Nguyen, who is joining us on the back end and moderating and making sure everything runs really, really smoothly. She'll be popping in a couple of helpful links into the chat throughout, such as where you can find our course materials and recordings. We will also be talking a little bit about the full-length courses that you can, consider this a little bit of a sample of. The IT Masters and Charles Sturt University run a variety of industry-focused qualifications in the IT space. And you are able to get some short courses, you're able to get some course credit towards a full-length postgrad course, whether that be a graduate certificate or a master's degree, by completing successfully 3 of our short courses. So you can navigate, if you're interested, to the link that Lily has also just popped in the chat as well, talking about the different courses that we offer, as well as the eligibility form, which you can fill in to have a look at whether or not you are eligible to start studying with us, and if you are, whether you are able to claim any recognition of prior learning based on your previous experience and qualifications. So that is pretty much our housekeeping done. One further thing is, if you have questions about the short courses admin themselves, if you have any issues, you can email shortcourses@itmasters.edu.au as well, and they should be able to help you out. So we're about to just start the webinar proper. So thanks again for everybody joining us. And we'd also like to acknowledge, before we start the webinar itself, that we are broadcasting to you today from the lands of the Wurundjeri people of the Eastern Kulin Nation and the Gadigal people of the Eora Nation, and pay our respects to their elders, past and present, and acknowledge the ongoing connections to lands, waters, cultures, and knowledges, and the unbroken sovereignty of those people over those lands. So everything seems to be all in order. And I'd like to welcome for the first time, so hopefully everybody makes him feel very welcome, one of our new mentors, Dr. Rich Lane, who is a living, breathing example of the trajectory that these ITM short courses can in fact take you on, as he engaged in our short courses first before going on to complete a master's degree with ITM and CSU. And now look where he is. This could be your future if you choose to study with IT Masters. Take it away, Rich. Thank you.
All right, thanks for the introduction. I just want to check you can hear me.
I certainly can.
Okay. Thank you very much. So looking forward to today's webinar. I shall start the slides. Just confirming you can see that.
Correct. Yes.
Okay. Okay, so we'll get straight into it. I've actually got a slide to introduce myself a bit later, but I wanted to start with blockchain fundamentals and what we are and what we're not talking about this week, and what I aim to sort of impart knowledge of in terms of blockchain. And I just want to sort of start off and say this is a strong introductory course of blockchain technology, where we're going to look at starting from where it came from, its origins, its concepts, and some real world examples. We're not necessarily going to be jumping straight into cryptocurrency or trying to sell you coins or recommend anything like that. We're going to be focusing on how the technology works and what makes it secure, what other industries are using it outside of finance, to logistics, and sort of looking at its potential in real world cases. We're going to break it down. We're going to cover topics like hashing, consensus, transaction security, and sort of see how all the data is stored in transactions and on the chain, and how it's all secured without relying on a central authority. We will briefly touch on cryptocurrency because it's one of the earliest and probably the most visible elements of blockchain. But I'm mainly here to give you a underlying infrastructure understanding of blockchain. I want you to be able to say, if you're at a party with friends and they say, what exactly is blockchain? You'll definitely have the answer for it. So that's what we're aiming to achieve in these courses. So I've just outlined who gets the most value from this course, and I've covered a certain number of areas, and obviously professionals seeking to understand the fundamentals. I'm sure everyone knows what cryptocurrency is. I know in Australia there's quite a large percentage of people that just own cryptocurrency, but they might not understand exactly what those numbers mean in their wallet, or how those numbers are secure in their wallet. So I'm also wanting to talk to business leaders and to understand blockchain's technology. There's a lot of elements to blockchain, such as identity and verification, that blockchain is very fundamentally built that can solve real world problems. Obviously, general learners that have an interest in blockchain or even IT in general, I welcome you to this course, and I hope you get some value from it. And then touching back on people that probably already know what blockchain is, or probably I've heard of it, or definitely know what cryptocurrency is, but want to deepen their understanding of how it all works and what everything means. And when you do a transaction, what actually happens in the background and how is it secure, rather than just the words that you hear. So I've got a little bit of agenda for this week. We're going to cover what is blockchain. We're going to define it. We're going to say, well, how was it made? When was it made? Maybe even who made it. We don't really know. But what we're going to do is we're going to cover some elements to describe how blockchain works, and why it's actually called blockchain. We're going to quickly talk about the problems that it can solve. I've alluded to that just now with some of the identity and some of the supply chain and some other things that we can talk about. We're going to talk about early concepts. So blockchain evolved from previous examples and previous knowledge. And we're going to sort of quickly touch on them and the mechanisms and ideas that led up to how we have blockchain and how modern cryptocurrency actually was formed. We're going to talk about notable early prototypes and ideas, examples of early blockchain systems, and again, real world cases where blockchain is being used outside of cryptocurrency. I'm going to quickly cover the other weeks as well. Week 2, we're going to introduce cryptographic hashing, which is one of the main elements that makes blockchain secure. It makes data, it gives the data a data immutability, which means it's tamper-proof. We're going to talk about digital signatures, how that can work and how you can sign certain pieces of data and validate that something exists at a period of time, or you can prove something exists between two parties that don't trust each other. We're going to break down what block and what chain means, what transactions are, how they're grouped, and how they're stored. Very important, we're going to look at the consensus mechanisms. You may have heard in your cryptocurrency conversations the concepts of proof of work or proof of stake. We're going to talk about their roles in validating transactions. Then we're going to do a brief comparison of consensus types, trade-offs, and examples. Week 3, we're going to look at blockchain architectures, public versus private, and hybrids of them. What's the difference? There's most, and I have to be careful in saying this, most people consider blockchain only blockchain if it's decentralized, but decentralized means there's no central authority and participants on a network don't necessarily trust each other, but blockchain creates trust. So there are examples of centralized versions of blockchain or institutionalized versions of blockchain. They do solve particular problems, but trust is a bit different. They have to actually trust the people that are presenting the product rather than the decentralized nature. Smart contracts, so I'm sure you've heard that name. What exactly they are, some examples. Data storage, we're going to talk about the concepts of on-chain versus off-chain. So on-chain means data that's stored on the blockchain, and off-chain means data that's just referenced and stored off the chain. Several examples. Then we're going to talk about integrating blockchain into business systems through API and middleware, how that can improve legacy systems, how you can put legacy systems on the blockchain or allow them to be accessible and validated via blockchain systems. And then week 4, we're going to get a bit advanced. We're going to talk about zero knowledge proofs, which is actually quite a new concept, but it's a very interesting topic, and I won't start to get into it now because I won't stop talking about it. But the security considerations, trust, immutability, and risk management. So how the data is stored and how it brings trust and immutability to that data. Interoperability, how we can connect different blockchain systems and connect to other systems in general. And then we're just going to start to wrap up a bit. Summary of the key challenges and opportunities. Closing discussion. What have we learned and what's the future of blockchain? Where's it headed? And what are some of the emerging use cases? So this is where I turn on my camera if I can find the button. I don't know where the button is. I was going to turn on my camera. There we go. Hello, I can say. My name is Dr. Richard Lane. I'm currently the Chief Technology Officer at One Orange Cow and Data OT. As alluded to before by Jack, I completed my doctorate at DBA from California Southern University. It was actually only last year. I also got my MBA at Charles Sturt IT Masters in 2017. I actually went through this whole educational course because, and I started on these short courses, and it was such a great format that I just kept going, and 10 years later, here I am. So much appreciative of the system. So I'm currently a casual academic at another university, but that's part of another program. I'm currently the president of the Doctoral Student Association for 3 universities in America. I've completed 3 blockchain. I've got awarded 3 blockchain patents or patents, depending how you say it. I also won the 2019 Blockchain Australia Award. That was called the Blocky Award. For Business of the Year, it was a blockchain hardware device that we created. I'll stop my video. Okay. So getting straight into it, we've got a definition here that I've quoted from a resource which you can actually look up as a reference section. But blockchain, first of all, can be defined in this manner, but it can be defined many different ways. So I've just chosen one particular definition, and it doesn't cover every single blockchain option or possibility out there, but loosely said, it can be defined as a distributed ledger database system for recording transactions between third parties that are verifiable and permanent. There are cases where that's not, but if you wanted a pretty good definition of blockchain, that would be it. Now, what does that mean? Well, blockchain is usually, and I've said usually because it's usually a distributed or decentralized digital ledger that records transactions across a network of computers in a secure, tamper-resistant, and transparent way. And what that kind of means is that every node or every computer or you might have heard the word miner, that's connected to a blockchain network is having a copy of all the transactions. They all compare notes and keep a record of it. I could loosely put it at very simply as everyone has a really long Excel sheet with every different transaction that's ever occurred forevermore and that's ever been. And that's what in this case what a ledger means, and obviously that's a very loose way to describe it, but perhaps an easy way. So each record or transaction is stored in a block that's cryptographically linked to the previous block, and that's the concept of chain, blockchain. You have a block with a number of transactions, and there's a hashing part that happens that says, okay, I'm going to hash this, and it is a hash of all the previous blocks. And what that means is that you can create an immutable trail, so it cannot be broken. If that hash does not match up, something has changed. So, and we'll get into that as well. So, this structure ensures data integrity, transparency, and decentralization, and removing the need for a central authority. So blockchain is run by volunteers. I'm sure institutions are also contributing to it, but the primary goal of most blockchain systems and Bitcoin, if you wanted to take an example, is a decentralized nature where no one person is controlling it, and that you provide trust by having all these people having a copy of the same ledger, the same transaction logs. So I've used the word digital ledger. What is a digital ledger? Well, it's a log of transactions done on the network, as I've stated before. And each full node takes note of the transaction and keeps a copy of all transactions. I've jumped ahead a bit. So then, okay, what is a node? Well, a node is a computer or a device that connects to the network. It connects to the blockchain network, and they communicate in obviously a agreed manner, and they participate in validating and recording transactions. Each node keeps a copy of the blockchain ledger and ensures it. So, as I've said, a node is a computer. It could be an IoT device. It could be a mainframe. It could be a phone. It also depends on the blockchain network. On some blockchain networks, you need, depending on the type of work that's required. A node might be required just to connect, but a node might be required, for example, in Bitcoin, to process a puzzle to determine a reward. And there's different reward mechanisms on different blockchains. And I am only talking about cryptocurrency here, but if a node just happens to be a connected computer to the network, and loosely put, the more nodes that you have that are spread out, decentralized, the more data integrity that you can achieve. So what is decentralization? You hear me say that word. Well, it means that no single person or organization controls the system. Instead, control is shared across many independent computers, called nodes, making it more secure and transparent. I'm jumping ahead of slides here, but basically it's like any other network that you would have, and they connect to each other and validate transactions, I should say. So I have an interesting slide next, and it's quite appropriate because the question is, do you need blockchain? And most of the time, the answer is very obvious, and that's the answer: no. Blockchain has specific use cases, and it shouldn't just be applied to everything as a nice to have. It should be applied to use cases where certain validations need to happen, certain identifications need to happen, and certain trust situations need to happen. Obviously, finance is a very good example of that. There's been especially when blockchain was blowing up in about 2000, well, Bitcoin, I should say, in about 2017, 2018, it was attached to many projects, and many projects got greenlit because, well, it's going to be powered by blockchain, and they failed because they could not either adapt the technology to what they wanted to do, or it was not a good product fit for what they wanted to do. A classic example would be the Australian Stock Exchange. They unfortunately invested in the wrong technology, perhaps the wrong partners, I'm not exactly sure, but they had to just back out and create a different system because the one that they created was not necessarily fit for purpose. So blockchain needs to be thought out and applied in the appropriate manner. I also want to add just on this slide that blockchain doesn't necessarily need to be front and center. Companies don't need to advertise powered by blockchain, as if, for example, right now, AI is quite a buzzword where AI seems to be attached to quite a few things, which is great. But I'm sure in a couple of years it will find its place and be a bit more less in your face, and be more of a tool. So blockchain should be used as more of a tool to solve problems, and it's not necessarily something that a customer or a user needs to know about, because they want something that's trustworthy, they want something that's fast, they want something that's reliable. Blockchain can provide those, but so why blockchain? I've covered this just a little bit. It solves trust issues between data sharing. So if you have a series of people on a network, or a series of people that don't trust each other, for example, the classic example is potentially shipping, where people are shipping things between different ports, and there's, I'm not saying anything bad about shipping, but maybe there's potential for fraud or there's potential for tampering. You can provide a mechanism to say this piece of cargo was tracked and logged at this particular date with these particular properties, and it went through these particular channels. I know, for example, Australian Beef had I think they had a trial with blockchain. I don't know if it went through or they're still using it, but they were trying to validate the source of all meat, so that eventually you could trace all the way back without any doubt there was any changes to the data, the source of the data. So if it works very, very well, if there's a distrust between parties within a network, and that ensures transparency. So on a decentralized system, you can just say, well, yes, I did that, and here's the proof, because you can point to it in a public, if you were using a public blockchain, it's right here, and it's not, and there's hundreds of thousands of copies all around the world, and it will be permanently in that ledger. So it prevents tampering with immutable records. Immutable means that it is what it is, and it won't be anything else. You can't tamper with that. It's there forever. It's a permanent record. It reduces the reliance on outdated legacy systems. What you can actually do is, if there is a legacy system and you have a shipping tracker or something like that, you can actually do things like validate data by hashing it. And if you put a hash of offline data, and a hash means I'm going to take a snapshot of that piece of data and put a cryptographic hash into the blockchain, then if any of the data changed, so would the hash. And a hash means just a number representation or a string that represents a series of data, or an image or a record or a series of records. And if any one of those changes, so will that number. So it can actually validate offline data and keep people honest. And then secures decentralized control. Obviously, you've got speed with financial transactions. You've got speed with passing information between and proving things. And then efficiency with automated verification. So you could do systems where blockchain could be used for voting, where you voted on something and your vote goes into a blockchain and it's very public. Obviously, your information will not be there, but you would create a facility so that you didn't suddenly have 100 million more votes, because every single vote was created from a particular machine with a particular person, and that vote could be put into an immutable chain, which is public, and everyone could see that. So there would be no counting errors potentially. So why blockchain solves trust issues in data sharing? So everyone sees the same updated information. So in blockchain, everyone has the same data. So it's not like, well, you have this data and I have a data that's 10 minutes later. Everyone has the same data. Everyone has this. It's like sharing the same file, but it's distributed. So the records can't be changed. No single person or company controls the data. Now, I'm sure there's some questions flying in now that says, what about the 51% ownership of a chain? Yes, that is a problem, but that's a rare case. You would choose a blockchain network that wouldn't have that problem. So if you were to make your own blockchain network and you had 10 friends on it, and 6 of them decided to not tell the truth, then that would be the answer. So the reason you have a decentralized is that no one knows each other, and blockchain actually gets its power by no one trusting each other. So everyone has to be honest because no one trusts each other. So so the system checks itself to make sure the data is valid, and that's the power of blockchain. And it builds confidence between people and organizations. So again, if there's a trust issue, you can use this mechanism to establish trust. So blockchains create a single source of truth using immutable records. All the data entries are cryptographically verified and timestamped. Trust is established through consensus mechanisms, not central authorities. And we're just about to touch on what consensus is. It removes the reliance on third-party validation. So you don't need to have an escrow. You don't need to have a a JP sign it because they're the trusted third party that's going to validate this person to this person. Blockchain can actually accomplish that. The data is transparent yet secure, so everyone can see it, and improves confidence. So, and it helps combat fragmentation, inconsistencies in data sharing. So it is what it is, and it won't be anything else. So there's no concept of version 1, version 2. Everyone has the same data. So what is consensus in blockchain? It's actually a critical element, and I'm not going to get too technical here that I could, but basically saying consensus in blockchain is explained as an idea that a fact is accepted as true if enough participants agree on it. And that sounds a bit crazy. So if you have 6 people in a room and they say oranges are blue, in blockchain, oranges are now blue. So that's what the 51% problem that people might have heard about. But in how blockchain does it is it leverages the theory through distributed consensus mechanisms. So what that means is that the truth will always come out, meaning that if you've got enough people not trusting each other, people have to trust each other. And how consensus works is that one node sees a transaction, and I'm being very general here. One node sees that a transaction occurs. The node next to it, and I'm being very general, says, I witnessed that. That is true. And then it continues on into the network. So in this in blockchain and consensus, truth is based on agreement, not absolute proof. And it might sound crazy, but if you have a small number of people on a blockchain and people are being chaotic and not doing the right thing, you're not going to have an agreement. So the truth is based on agreement. So the consensus, literally the word consensus, determines the truth. So if enough participants agree, it's accepted as true. And this creates the ability to not have that central authority. You don't need the judge. You don't need the policeman. You don't need the third party to say, the mediator to say who said what. Everyone has the same information. So it works when even people don't touch each other. We've mentioned that. So I've put an analogy here. Consensus in blockchain is much like a group of people deciding where to eat. The final choice might not be objectively correct, but once a majority agrees, it becomes the accepted plan. And that might sound crazy, but that's exactly how blockchain works. And it works on consensus. So basically, in blockchain, this analogy relates to how data is added and accepted. Just as a group decides on the restaurant through majority agreement, the blockchain accepts a transaction when most nodes agree it's valid. There is a concept of where, let's just take Bitcoin, for example, that 2 nodes agree, decide something at the same time. In this particular case, the node with the longest chain, which means the most number of people that agree it's true, wins. So that's how you may have heard the term forking, where data is not agreeing with each other. That's how, in this case, Bitcoin self-heals itself. So that is slide 20. I think we're going to have a stop for some questions.
Absolutely. And I would just like to remind people as well, if you've got questions about the content that you'd like to have answered on the stream, please direct those to the Q&A section rather than to the chat section, because I can see a couple of, I've seen a few questions that I think would be quite interesting go through the chat. And unfortunately, there's just too many people posting in there for us to be able to dig those out all the time. But we've got, now we've got a bunch of questions coming through. I suppose we've got a question that I feel has potentially been somewhat answered, but might, benefit from a little bit more exploration. We've been asked, if a blockchain with more nodes is more trustworthy than that with fewer nodes? And is a blockchain with only one node considered trustworthy?
Um, it it trusts itself. So with one node, I wouldn't call it a blockchain. It would be more of a single computer. Um, you could do it, but you wouldn't have a decentralized network. And if someone was to say, "Hey, I've got one computer, it's on blockchain," the person saying that would have to be an authority. So it would have to be a government or something like that that says, "Hey, we're on blockchain." Thus, you're not trusting the technology, you have to trust the government in that case. So the it takes away a little bit of third party trust in that case. So yes, it's possible, but yeah, you're trusting the entity that's running it at that point.
Right. Thanks very much. That's great clarification. And we've got a question from Don who asks, how much latency is there across consensus, and is that a problem?
Um, no, um, it it depends on the blockchain you're using. So there are really, really rapid blockchains now. And this would, if you'd asked me that question 5 years ago, this is a really good question, by the way. If you'd asked me this question 5 years ago, I would have said, yes, it is a problem. But no, it's not, because there are now blockchains that are actually faster than credit card um, transactions in terms of transactions per second. And there's actually a couple out from Australia. There's one called Red Belly Blockchain, which is made in Australia, and it has a really, really good potential to do a lot of big things. So I encourage you to look at that, do some research. It's an interesting topic, but yeah, it's not really a problem now. You just have to pick the right blockchain.
Great. Thanks very much. We've got a bunch of really interesting questions that have come through. Again, to all of the participants, we're not going to be able to make it through all of these questions, but I definitely encourage you to direct those questions if they're not able to be answered to the forums on your Moodle. So that's learn.itmasters.edu.au, where other students as well as Rich will be able to discuss these with you. I guess let's do maybe two more questions. We have a question requesting some clarification on, can you explain the consensus process, and is it like agreeing on the hash value?
I just want to add, we'll have some more questions at the end, but
Oh, yes.
yeah,
Sorry.
that's okay. So the consensus mechanism is actually a little bit different per blockchain. So it's actually called a consensus layer, and there's several layers in a blockchain. And I I encourage you, if you want to get more technical, to jump in the forums. And this is just an introductory course. So yeah, I just want to say that there are different ways to do it. Um, and it really depends on the blockchain that you want to do. So I don't really want to get too technical. So, but do ask the question on the forums, and I'll fill you in.
Great. Thank you. And let's go with one more. Oh, some of these actually, I think I might say let's move on, because I think some of these are probably going to be answered in further content. I will be able to answer, though. David Salone has asked, what was the Australian blockchain? I believe it was Red Belly Blockchain.
Red
Is
Belly
that right?
blockchain. Yes,
It's a
it's
great
correct.
name, especially if you know
Yeah,
anything about Australian snakes. All right, back to the content. Thanks very much, Rich.
no problems. Uh, So yeah, timing matters in blockchain. This is actually very relevant to the previous question, but especially, and I actually touched on this, when two versions of the truth compete. So, and that's under various circumstances. So if I was to take an example of mining on Bitcoin, it is when two people solve the puzzle at the same time. And the way the truth is found, or way it is accepted, the fair way to do it is, well, let's figure out who actually did this first. So what they do is each block is time stamped, so the network knows which comes first. And they look at the chain length. So the longest chain, and again, this is different per blockchain, but in general, the longest chain with the most work or stake is accepted as the truth. So even though two people came out with the same piece of truth, they're going to say, well, this guy did it first, or this block came first. So consensus rules: if two blocks appear, a fork in the chain is generated. Nodes temporarily follow both until one grows longer, and then they all switch to that new version. So forks sometimes can be really, really bad. You might hear the media jump up and down about, and there's been some serious forks that have caused problems in some other blockchains. But generally, it's a way for to accept when there is a little bit of doubt to who was the first person, and there's rules around that. So this is really interesting. We're going to start talking into the blockchain origin. So how did we get to blockchain? How did blockchain get to what it was? So straight away, I mean, blockchain was introduced in 2008 in the white paper Bitcoin, a peer-to-peer electronic cash system. You can look that up. I think it's on bitcoin.org, or it might be, you can probably get it pretty much anywhere. But it's credited to Satoshi Nakamoto. We're not sure who he is. I'm sure that's going to remain unknown. I'd love to know myself, but it's widely believed to be a pseudonym. So the author is still debated. Could be one person, it could be multiple people. Nakamoto sounds Japanese, but the language that was used in early forum posts and even in the paper itself seems to look like they're a native speaker. Obviously, that's a bit general, but so while the mystery is intriguing, Nakamoto's identity is not relevant to the technology use or research. So it's a mystery, but we must thank them, or those people, for contributing to creating blockchain. So early concepts behind blockchain. So while blockchain emerged in 2008, some ideas dated back in the 1970s. Concepts of distributed systems started to come out. So having the early first methods of decentralization. Ralph Merkle introduced Merkle trees, and that enabled multiple hashes to be represented with a single hash. So that's the fundamentals, the start of what a chain is. David Cham, I hope I said his name right, Cham, proposed digital cash using cryptocurrency, one of the earliest blockchain-like systems in 1983. That was just as a white paper, I believe. And some of these examples laid the groundwork for modern blockchain technology. So I'm going to sort of do some parallels to how you can describe blockchain, or some concepts that, at least in my research, blockchain kind of similar to. I'm sure other people have various other ideas, but blockchain is similar to RAID arrays. And again, every blockchain is different, but let's just say it combines multiple physical drives into one logical unit. So in this case, it uses striping and it splits it across multiple disks. So it's a little bit different, but it does have the fault tolerance and redundancy, and it's not centralized. It's not all in one hard disk. It's spreading everything out to create stability. So striping, again, that's a one-to-one copy. So in RAID 0, you might call it mirroring as well. So it splits the data into blocks written across multiple disks for speed. So this is an example of redundancy. This is an example of making sure everyone's got the same copy. So if one disk fails or one node fails, there's nothing lost because everyone has the same data. It's also very similar to BitTorrent. If you're familiar with BitTorrent, it's a peer-to-peer. BitTorrent is a peer-to-peer file sharing protocol, and the files are broken into pieces and distributed across multiple layers. They actually use hashing to validate blocks as well, to make sure that you've received the correct information. And it's decentralized by design. Both users download and upload and it ensures efficiency by being resilient to chain. If the original person that shares the file goes offline, then the file can still be shared. So it's very similar to blockchain, and I've made a little bit of a comparison here to BitTorrent and Bitcoin. You might see the familiarity there. So here, BitTorrent shares large files with many users, and Bitcoin transfers and records in digital currency. They're both peer-to-peer. Nobody, so nodes share and verify transactions, and nodes in BitTorrent are done with files. So no central person is controlling it in both cases. So once it's put into the network, it can stay alive forever. In Bitcoin's case, it will. And then, so yeah, I mean, there's incentives for Bitcoin, obviously, to keep nodes up, and incentives for BitTorrent is just if you want to get a file, or you want it, it's self-fulfilling. So blockchain, why does it matter? Each of those ideas solves a specific problem, and together, that's what made blockchain possible. So cryptography made data secure and private. Merkle trees made data easy to check without downloading everything. Digital cash showed how money could work without a bank. Timestamping proved that something could be created, or when something was created or changed, and gave immutability to that data as well. And blockchain combined them into a secure shared system with no centralized control. So blockchain took elements, or maybe I should say Bitcoin took elements of a few different things, a few different ideas to create it. And it's very similar to an Isaac Newton, which is, I've seen further by standing on the shoulders of giants. So blockchain isn't one invention. It's the result of decades of innovation coming together. And a lot of people wrote a lot of papers and a lot of research, and posted on forums and mailing lists, etc. And that actually came out within the Bitcoin white paper. A lot of that was actually referenced. So it's a combination of a few things, and it came together to form something. So early concepts, there was a concept in 98 called BitGold. It was one of the earliest proposals for a decentralized digital currency. It combined cryptography, timestamping chains like blockchain. It solved the problem of proof of work without needing a central authority. It was never implemented, but it strongly influenced Bitcoin. So it was just a concept. It was described as a way to mint unforgettable tokens without a central bank. You might have heard the word tokens as well being used to describe units within a blockchain. So it was conceptualized in 98, but there was an update also in 2005. It was a large detailed blog, which again is before Bitcoin came out. In also 98, B-money was proposed. It was a money system run by a distributed network of users. It introduced concepts like smart contracts, public key identities, and it had a ledger. This was actually referenced by Satoshi Nakamoto in the Bitcoin white paper. And then, yeah, it was showed how money could work without needing the trust of a central authority. So this was one of the first examples that came out and showed how decentralization could work without a trust mechanism. So I've just theorized here. This obviously no one really knows the answer, but perhaps why these failed was Bitcoin proposed a way to create value but lacked a way for a network to agree on that value. They didn't have a consensus layer. B-money, imagine peer-to-peer money, but it was never implemented or tested in the real world. I think that's just unfortunate. It did have potential, and I probably say that, and I guarantee you there's someone in the world that actually has written this but it just hasn't been didn't catch on like Bitcoin did. So, and both lacked working incentives to motivate participation. Bitcoin gives participants a number of coins for participating. If you actually, I should say that again, they get the opportunity to be rewarded in some Bitcoin for participating. They had clear consensus mechanisms to resolve agreements, which was very important when there was a disagreement. And obviously they got a live network to prove the concept. So Bitcoin was developed and proven to, well, this actually works. So I've got some other examples, and I know we've talked heavily on cryptocurrency, and I told you we wouldn't, but examples of blockchain are voting systems where people can vote onto a public ledger that everyone could see that there's one vote for this person, and that person voted in using this machine. This all could be hashed, put onto a public record that everyone could see. So tamper-proof, transparent, verify elections. So you could run a complete election for a country. I know there was a local blockchain policy group that actually ran their elections using blockchain. So, it doesn't have to be a country. You could, if you were interested enough, you could create an election for the school captain. It doesn't really matter, but yeah, it would be tamper-proof, and it would be very, very transparent. So supply chain tracking, this is a classic example and probably an overused use case, but it can support do supply chain tracking quite well, where if something's passing through multiple hands, those hands don't necessarily trust each other. But also, for example, the consumer, if they're buying something, they want to know where something came from and that it's actually true. So, for example, diamonds could be traced back to the source that they came from, because once they're mined, they're put onto the blockchain with information that verifies its size, its weight, its color, etc. And that information could never change. So from coming out of the ground to being bought in a store or wherever it might be, you could trace that back. And if you think about that for a lot of different things, there's other situations like there's a concept called conflict minerals, where there's a lot of minerals that are put into modern technology, and even the companies that manufacture the products don't know where the minerals are coming from, where the aluminium's coming from, or the zinc, etc. So this can, and I'm not saying it's the be all and end all to fix everything, but it can provide proof to customers and to people in a supply chain where materials have come from and their source. So so it can produce provenance and authenticity. I've talked about the Australian beef export example. So I'll just say a real example. If everything was on blockchain, you could potentially put a QR code, and then when you're in the store, you could scan it, and it would show the exact trace, immutable, without a doubt, where this came from, how old it was. And then if you start to get really into it, you could track. It was chilled the entire way. It was it never left the country. So if something, I know for certain countries, they have authenticity problems to say this is authentic Australian beef, or this is authentic Japanese Wagyu or something. That could make the customer know that this is definitely what you're saying it is. Identity management, you can prove someone exists. You can prove that someone is somewhere by saying, I tapped a card here. That card then stores that information on a network. You can also put, I've seen examples where people have taken a photo of themselves and taken a hash of that photo and then put that hash in the blockchain. So there's an example of personal identifying information where, for example, if you were to upload a photo of your passport um, to, let's just say, the government that wanted to validate um, your identity, you could actually send them the blockchain link and then send them an example of your image. And then if they matched, then you don't actually have to share your images with the people, because there's a third-party blockchain independent record in the public space that's identifying you. So it's very good for identity management. And I'm kind of butchering that example a bit. There's I know there's a lot of Australian companies that are doing that right now, but so yeah, secure decentralized control of personal data, health records, healthcare records where you don't want things to change. And again, that's probably an offline example. Private interoperable and audit-friendly data sharing, smart contracts, automated agreements, etc. So real estate could be done. There's a case example of deeds for housing and things like that that could be put or is put on blockchain. I'm going to accelerate a bit because I'm cautious of time, but blockchain is a trusted third-party validator. Traditional systems rely on central authorities, so blockchain can fix that. Every action is recorded, timestamp, visible. So this verifies ownership of assets, builds trust in systems, and blockchain can become the source of truth for everyone. So everyone can see it, but no one can alter it. So there's a couple examples here. I'm going to Bitcoin as a public record. So I've talked about immutability and putting hashing and stuff. So how does it actually work? Well, Bitcoin can actually store 80 bytes of data in a transaction, and that is just about the right size for a hash. And a hash is a string that represents data, or a series of data. And it's commonly used for documents or file hashes, short text tags, asset records. So you can actually put a record. You could put the word hello in there if you wanted to. And that data would become permanent and public. So it lets you prove something existed at a certain time. So if you said, I was here, I tapped my card at this time, or I voted at this time, it could be put into, in this case, Bitcoin, and that would prove that this person did this at this time because it's timestamped. So blockchain apps as a tamper-proof timestamp, but not necessarily as a storage system. I mean, it's not a file system. So Ethereum as a public record, again, it can do it. They have much longer they have much more than 80 bytes you can put in there, but it is at a higher cost. You actually the transaction fee increases, and it's not, you don't necessarily want to store a lot of data in Ethereum, but you can. It's more flexible in storing messages, and it tends to be more resource intensive and costly is the example. So larger data is normally only referenced again by a hash, with the full contents being offline. And this is just another example. So wrapping up week one. So I'm just covering what we've explored, and please ask more questions as well. But yeah, we've covered what is blockchain, the origins and evolutions of blockchain, early ideas that paved the way, like B-money and Bitcoin, Bitgold, I should say, real world examples driving its development, and how messages are stored. In at least two examples, there are obviously others. Next week, we're going to talk about, just recapping, hashing, and that ensures data integrity, how digital signatures proving authenticity, the blocks in the chains, how they're grouped and how they're linked. So we're going to get a little bit technical. And if you're wondering exactly how it's going to work, we're going to cover that. We're going to get more into the consensus mechanism, and we're going to look at POW, which is proof of work, and proof of stake. There's others as well, but we'll talk about them as well, with some real world examples. So last slide. Any questions?
There are quite a number of questions here. Given that I don't know a huge amount actually about blockchain, would you like to select some of these questions from the Q&A section that you feel are the most interesting and relevant?
Yep. Let me just change my screen to have a look. Q&A. So there's a question from Don. What are the variables that increase cost and power consumption requirements? So I'm assuming for mining. So this depends on the blockchain you're using, and we're going to talk about this next week. So this is a good, you'll definitely be told next week. So proof of work is something that increases the power consumption. And everyone says, oh, blockchain's power intensive. It's actually just Bitcoin. And being the most popular, it's using an old mechanism, or one of the earliest ones, called proof of work. And Ethereum, to take for example, uses proof of stake now. So it uses far less resources um, than what Bitcoin does. So it's an answer that's different depending on what you use. So yeah, don't let people say, oh, blockchain's not good for the environment. It's vastly improved to what it was. And if I would say the argument that AI data centers are probably up there as well in these days. Um, so I'm gonna look at some other questions. How does a single node claiming that a transaction is true make it believable by others? I think I've answered that, but I'll just cover really quickly. Um, it's really the first person, and that's determined by the length of the chain and how many people have agreed to it. So if you've got a room of 100 people and 20 people say this is true and 10 people say this is true, then the 20 people are going to win because that person came first and they have more people agreeing with them. And that's a really simple way to answer that, but that's how consensus works. Um, is there any opportunity to question the integrity of a transaction? That's not needed. That's baked in. If you have to question the integrity of a transaction, you have to question the integrity of the blockchain that you're using. So that's what makes blockchain what it is. It gives you that trust mechanism. So the only way you would not trust a transaction is, and I think what you're alluding to is, for example, in Bitcoin, you might not trust a transaction until you've had what's called 10 verifications. And what that means is 10 nodes saying, yep, this really exists. You can actually wait to 50 or whatever you want, but you're basically waiting for a number of people to agree that a transaction has happened. So generally, you don't have to wait at all, and that's just an example for Bitcoin. So if there's a lot of questions coming in.
There are a lot. I'm so sorry. Usually I'm
That's
a little bit
okay.
more active in the question process. But I truly don't know very much about blockchain. This has been a very
That's fine.
interesting course for
How
me. I'm gonna say
secure?
maybe two more
Yeah,
questions,
that's
maybe
fine.
three.
These are really good questions, by the way. So please post them on the forums, and I will get to as many as I can. How secure is blockchain technology from cyber threats? One single node is compromised. Will it affect all the other nodes? No, it will not. So obviously, I say that, and there's always new threats coming out. But if one single node is compromised, that's the integrity of it. The other nodes around it will say that person's not telling the truth and ignore them. So that's the consensus. The consensus will be ignore that guy. And there are actually mechanisms to punish nodes that say, sorry, you're off the network now, for take a chill for, I'm sure there's instances when nodes misbehave just because of configuration or something. And they just get punished and they get removed from the blockchain or potentially banned. So I'm going to do a couple more. Why is the uptake of blockchain technology so slow? I think it needs to have its place, and you'll be surprised how many people actually use it. And it's a background tool. I know various systems. A lot of banking transfers now, bank to bank, are done through blockchain. So, and you just don't even know about it. So, I think the uptake is slow because it's not necessarily needed. But I also think it has its place, and where it's being used, it's just not being advertised. So, all right, lucky last question. Oh, this is a very good question. Is quantum computing a real threat to blockchain? Now, this is debatable. It is a threat, but it's not a threat because um, so it's been discussed in the Bitcoin forums. So Satoshi actually said in his own post, if quantum computing came out and it became a threat to blockchain because it could break all the cryptography within seconds, there are quantum resistant, quantum proof, quantum resistant hashes out there. All you would have to do is change the hash to a quantum resistant one and then hash everything before it. So if you change the hash to a more stronger hashing method, it doesn't invalidate everything before it. You're just going to say at this block X, we changed to this hashing mechanism, and from that hashing mechanism used its method for all the blocks previous. So it's actually been discussed 10, 15 years ago. But the media loves to write stories about it and create fear. And it's not necessarily a problem. I'm pretty sure the people that are developing blockchains know this, but there's no need to change right now. So they just haven't done it. So, but very good question. Thank you, Frederick. I guess if there's any more questions, please. These are really cool. I'm glad to see you guys are interested in blockchain and the questions. So please post them on the forums.
Absolutely. And we are going to stop there just for time. But thanks so much, Rich, for this really, really informative session that we've had today. Like Rich said, please do contribute to the forums with your discussions and your questions. It really enriches the experience of all of the students to have all of that discussion on there. Thanks so much, everybody, for attending. This is the first of 4 short course sessions on blockchain. So you will be able to access the recording of this one within about 24 hours, either on Moodle, so that's that learn.itmasters.edu.au, where all of the course content and forums can be found, or via YouTube if you prefer. If you are very interested in this and keen to find out more, dig a little bit deeper, and maybe look at a variety of different topics, please do check out our range of full-length postgraduate degrees at the IT Masters website. We have both graduate certificates, which are 4 subjects, or master's degrees, which are 12 subjects available to study. And we've got some sessions that will be starting soon. We run a variety of sessions throughout the year so that you can tailor your studying experience to fit your lifestyle. Applications are currently open for session 2, which is beginning on the 14th of July. Or if that's a little bit too soon for you to consider studying a postgrad degree, term 3 will be beginning on September 1, and applications are also open for that. So if you are interested, do get in touch with our eligibility team, because this is a fantastic pathway into higher education and to further study in that, as demonstrated by Rich, who started out doing short courses with IT Masters and Charles Sturt University, which then led to him getting an MBA. So thanks very much again to all of the participants. It's been really, really fantastic session. And thank you to Lily Nguyen for moderating and running the back end of that, making sure everything ran smoothly. And thanks again to Dr. Rich. Hopefully we will see everybody back here next week. That will be at 7:30 p.m. Australian Eastern Standard Time, or the equivalent where you are. Same time, same place, essentially, next week. Looking forward to seeing everybody there. And in the meantime, please do utilize those forums. It's always wonderful to see everybody's engagement. Have a great rest of your day, night, morning, etc. And we'll see you soon. Thanks, everybody.
Thank you.